we're going to take a look at a polynomial function that's broken down for us, and we're going to learn how to find x and y intercepts. So we're going to start with the degree. The degree of this function is 1, 2, 3 x's, so I have a degree 3 polynomial. If I was to distribute all of this out, my first term would be x to the third, and so on. That means I could have a possibility of 2 terms. If it is a degree 3, and I know this is a positive degree 3 because there's no negative x term, that it would have to start down and end up because it's a positive slope. So just things to think about. X-intercepts. To find the x-intercepts or solutions of this graph, I'm going to take each function and set it, or each piece, each term, and set it equal to 0 and solve. So x equals 2, therefore one of my x-intercepts is 2, 0. So 1, 2. X plus 1 equals 0, so x equals -1. -1, 0 would be another x-intercept. X minus 4 equals 0, so x equals 4 would be another intercept, or they're also called solutions. So now here's my 3 intercepts. Let's talk about the y-intercept. The y-intercept is when I plug in a 0 for x. So y equals 0 minus 2, 0 plus 1, 0 minus 4. So what we're doing is saying -2 times 1 times -4. Therefore, my y-intercept is a positive 8. So now, I know I have to start somewhere down here and end up here, and I have to go through these pieces. So what my graph is going to look like would be something like this. It's going to turn here and have to turn here, and so my graph looks like this. Okay, so what do I have here? I have a turning point, or this would be a maximum, local max, and this would be called a local min because it's a minimum part of my graph. It may not be the lowest part, but it is a low part of the graph. And I'll show you on another video how to find those exact values using your calculator.